Okay, we are in the next section of your science. We are in chapter 10, and we are in the section labeled Visible Spectrum. Visible Spectrum. This chapter is all about light. This is on page 242. And beside you, you should have your activity manual study guide, page 163. So we are not going to do the back of the sheet you did yesterday. We're just going to put that aside, and we're going to go on to the study guide portion for this section. So keep that out beside you just like we did yesterday, and we're going to look over that as we continue reading through this section. There are some wonderful videos that will explain this in better detail to you and give you more visuals for this. I would love, if we were in the classroom, I would be showing you several of these different videos. One is Study Jams. If you go to YouTube and look up Study Jams Light, they have one on light that gives a lot of good information about what we're going to talk about, and they also have one on reflection and refraction, which we're going to talk about today. So I would, if you have time and internet ability, go to YouTube and look up those two Study Jam, Jams, videos and watch those two today if you have the ability to do so. Okay, let's look at these together. Page 242. If you try to walk through a dark room, you may stumble or bump into things. Without light, there's no vision. You see the objects around you because light bounces off them. Light makes things visible or able to be seen. Light also gives objects color. In 1672, Isaac Newton proved that light is made up of many different colors. Newton used a prism to separate white sunlight into a band of many colors. The different colors of light that we can see are called the visible spectrum. So the different colors of light that we can see are called the visible spectrum. Now, when I see a dark word like that, where should my eye immediately go? Study guide. Is it on there? It's number 1, isn't it? The different colors of light that can be seen are called, and then you should write in there, visible spectrum. Okay, the next section, refraction and reflection. Light generally travels in a straight line. The direction and speed may change, but its path will usually be straight. The matter through which a wave travels is called a medium. The speed of light changes as light enters different media. Light travels the fastest in empty space. It slows down a little when it enters air. So remember, we learned that light can travel in empty space. We saw that yesterday. And it goes the fastest that way. When it hits air, it slows down a little bit. Because that is the medium through which it is traveling. Things such as glass or water make light slow down even more. When it enters a new medium, light slows and can bend in different directions. Refraction is the bending of light as it passes from one medium into another. So as the light enters from the air into the glass, it's going to bend a little bit. So where do we see the bending of light? I see that on number 2, don't you? Okay, label that one correctly. Prisms separate light into colors by the process of refraction. As sunlight passes through the air and enters a glass prism, the light slows down and bends. Each color of light has a different wavelength, so each color bends a little differently. This allows you to see the separate colors. Refraction also happens in a rainbow. Sunlight passes through raindrops and bends into the separate colors of the visible spectrum. The colors in the visible spectrum are in order by their wavelengths. The reds have the longest wavelengths. The colors after the reds are oranges, yellows, greens, blues, indigos, and violets. The violets have the shortest wavelength of the colors. You can remember the order of the color groups by thinking of the first letter of each. The first letters spell out the name Roy G. Biv. red, orange, yellow, green, blue, indigo, and violet. So, number 3, the colors in the visible spectrum are in order by their, that one is the first sentence of that last paragraph I read, are in order by their, what did it say? You reading it with me? Wavelengths. Wavelengths. And then they want you to list the colors. The colors in the visible spectrum are, don't just put Roy G. Biv, write them out. Red, orange, yellow, green, blue, indigo, and violet. Okay. Refraction is one way that light changes its direction. When light hits transparent matter, the light passes through with little bending. Objects behind transparent matter are clearly seen. As light hits translucent matter, some light passes through and some is bent or blocked. Objects seen through translucent matter appear unclear. So sometimes glass, like if you have like a drinking glass, can be a little translucent where it looks a little filmy, and so you can't see yourself as clear as if I was looking into a mirror. Light slows down and bends when it passes through transparent or translucent things. Opaque matter does not let any light pass through. All of the light either bounces off the object or is absorbed or soaked in. So something that you can't, like this, it's opaque because I can't see any of myself in that at all. Okay, it's opaque. Light can also change direction by reflection. Reflection happens when light bounces off an object. Oh, where do I see bounce? Number 5. The color that you see is determined by which colors are reflected and which are absorbed. You see the reflected wavelengths as the color of that object. A red book reflects the color red. All the other colors of light are absorbed. When all the colors of light are reflected, when all of them are reflected, you see white. You see black when all the colors are absorbed. Why are darker colored clothes usually warmer? So people tell you in the summertime, oh, don't wear a black shirt outside when it's really bright and sunny. Why? Think about what we just said. Light colors reflect, but dark colors absorb. So what is dark doing to that heat and that light? It's absorbing it and making you hotter. Dark colors absorb more of the light energy from the sun. The sun's energy makes the molecules in the clothing move faster. The temperature of the clothing rises and keeps the person warmer. Interesting, isn't it? You wouldn't think that the color would affect how you would feel, but it does. Okay, so let's see. Do we have any other questions? Yes, number 6. The color that is seen depends on which colors of light are reflected to your eyes and which are absorbed. Is that correct? Yes, that's what this said just a second ago. When all of the colors of light are reflected, you see, and what did it say? Right there at the bottom of the next to last paragraph. When all the colors of light are reflected, you see white. Number 7 should be white. And number 8, when all the colors of light are absorbed, you see black. So number 8 should be black. Okay. And types of materials that refract light. I don't know if that means, I think number 11 is wanting you to say the different types are transparent, which is almost what we would call clear. Light goes right through it. The next type is translucent, where light passes through a little bit, but it's not as clear. And then opaque. Light does not go through. Transparent, translucent, opaque. That's what goes on number 11. Okay, now let's look at colors. So now we're going to talk about primary colors and pigments and how all that works together. This is page 244. An amazing variety of color is all around you. Whether a beautiful blue sky or a bright yellow flower, the world is full of colors reflected from our sun and white lights. Scientists study color using the idea of a color model. There are different color models, but each has three primary colors. Primary colors cannot be made from other colors. God designed our eyes and brains to combine primary colors into all the other colors we see. The primary colors of light are red, green, and blue. So we are going to talk about two different types of combining grids here. One is the colors of light and one is the colors of pigment. This is what we draw and color with, okay? Pigments are what color things. This is dealing with light, how light is combined to make different colors. If red light, green light, and blue light are mixed together in equal amounts, I think I skipped some. The primary colors of light are red, green, and blue. All the colors of light are formed by different combinations of these primary colors. If red light, green light, and blue light are mixed together in equal amounts, they reflect all colors and produce white, as shown in the center of the model. Okay, so that's not the same as if you're taking paints. This is light. This is different. Television screens and computer monitors take advantage of this color model. Tiny groups of red, green, and blue light shining at different brightnesses can produce all the colors you see on a screen. Okay, so look at number 9. The what colors of light are red, blue, and green? Was the word secondary? No, the word is primary. The primary colors of light are red, blue, and green. These colors can be used to make all the other colors of light. Okay. And then 12 lists the primary colors of light. Red, green, blue. Each primary color has an opposite or complementary color. The complementary color of red is cyan, and the complementary color of green is magenta. What is the complementary color of blue? Okay. So if I look at the complementary color, that means, so it said green is magenta, I'm looking across. The complementary color of blue is yellow. Most objects in the world are not sources of light. Instead, they reflect light. The colors you see are those that are not absorbed by pigments in the objects. Pigments are opaque substances used to color other materials. So this is like paints or markers or crayons. This is opaque substances used to color other materials. So look at number 10. Pigments are transparent? No, what was the word? Opaque substances. The primary colors of pigments are, and this is going to go for number 13, yellow, cyan, and magenta. A lemon is yellow because its pigments absorb all colors except yellow. Yellow is reflected. Notice that the primary colors of pigments are the complementary colors of light. Paint pigments work the same way. You may have learned in art that the traditional primary colors are red, yellow, and blue. Pigments reflect these colors. Red paint looks red because it reflects red. A blue crayon reflects the color blue. When you mix pigments together, you do not get white. You get a dark, almost black color. This is because they absorb nearly all the colors of light shining on them. Color is a wonderful gift from God. When he said in Genesis, "Let there be light," he had already planned for his earth to be beautiful with color. He created the pigments and light to work together. He knew that a wide variety of colors would bring pleasure to people. Okay, so look at 14. Describe the relationship between primary colors of light and primary colors of pigment. So what does it say? It says right here at the bottom. Notice that the primary colors of pigments are the complementary colors of light. So that's how they relate. The primary, this is at the bottom here. This sentence right here is going to be your answer for that. Okay, now in the comments below, you should have been able to answer all of this. In the comments below, I want you to give me a color and then I want you to name it creatively. So, like they said, lemons are yellow, lemon yellow. And I want you to name, it can be any color. It can be a red or a pink or a blue, but I want you to give it a creative name, just like Crayola does to their crayons. I've seen a macaroni and cheese orange. So give me a color and then you creatively name it. I'll be looking.